Okay, I see the recording's going, so let's go ahead and begin. I'm just going to go through a few things. So, what is a data analysis plan? If you guys haven't encountered that, it's a bit of a jargon term and different, naturally, like all things in statistics, different applied fields have different terms for them. And why we want to do one. And then I'm going to spend the rest of the time on the template and a demo of what the Quarto file looks like and where you can get it if you're interested in playing with it. You can download both the template, but you could also download my little example, and you could adapt that one if you want a real version of that. Now, the data analysis plan, I'm just going to call it DAP, is in a lot of fields, it's called a statistical analysis plan, an SAP. I don't like acronyms most of the time. I do use them sometimes because I find them ironically funny, because they almost never serve any purpose other than to obfuscate what you're talking about. A data analysis plan literally does what it says on the tin. It lays out the background for a study and what you want to learn from any exercise in data collection. So it just is a formal way of communicating your study objectives, like your first year report would also do this. It goes further, though. A thing that very few reports I see from students, from research students, is paying any serious attention to laying out what the variables are going to be for the data that will be collected, and what the outcomes will be that you expect. This is a part that's usually not present in average practice, but it is an essential part of a real data analysis plan. Another thing that is suggested in your yearly reports for research students is to lay out what statistical methods will be used to analyze your data. Now, quite a lot of you that are present here today have come and talked to me about experiments, data collection, how to analyze it. What I find in most year reports is that this section is present, but it's very light on detail, far below an expected professional standard. And most students will be able to outline some statistical methods, but almost all students, until you build and get experience with multiple years of experiments under your belt, you'd benefit from visiting the consultant and talking through some of the options for stats, and then communicating those on a technical level that would be useful to other people, like your supervisor, or like a future student who might want to see what a good gold standard is. And then an outline of the outputs. The primary focus today is going to be on statistical outputs, but it could be other outputs too. And the most important part is that the data analysis plan is written prior to data collection. I wanted to say, before I move on to the other slides, is that the most advanced, the most refined practice for writing data analysis plans is in the field of medical biology, where clinical trials and journals that publish medical studies, they require a statistical analysis plan. They use the phrase statistical analysis plan in that field. They require that before any paper can be published, before any funding is dispersed for, say, field trials or clinical trials. And there is a regulatory requirement if it involves human patients for certain kinds of clinical studies that the government imposes in America and in the UK, and in Europe, and other countries too. And so there's a formal government oversight system, depending on what regulatory framework you're working in, for documenting the statistical analysis plan. Why did they go to all that effort? I mean, there are whole books written about this for medical studies. I say briefly as well, there is another group that do this to some extent, and that's in engineer manufacturing. They have a system called Six Sigma that overlaps, yeah, quite well with some aspects of statistical analysis plans, but not completely. And I'm not going to go into all of that. Those are the two fields that I'm aware of that have really well developed systems for communication. Now, for a lot of applied scientists, the rest of us, um, agriculture, ecology, environmental science, geography, geology, and all of the others that are outside of those ones I mentioned, all of them value the creation of a data analysis plan, but there are not good standards in place for it. They have increased, they've become better over the course of my career, but they are below the standard that many people would prefer, maybe most people. So I wanted to explain, I have gone over this before, but why would you write a data analysis plan before data collection? A lot of you, I'm not pointing any fingers, um, come to me for the first time after the data is collected. And really the help you're seeking is, how do I analyze this data? But um, the professional standard, the minimum professional standard really is to think about that before you collect the data. Well, it forces you to really parse down your thinking on the exact research questions that you want to answer. It prevents you from having the luxury of being vague on that and just getting on with doing your experiment. Um, and another thing is that in a lot of fields, there's a developed and robust literature. Probably the most well-known one is in psychology, but it certainly exists in agriculture and ecology as well, is that people tend to drift in a study. Like you might start a study thinking one thing and you learn during the course of the study and your focus drifts. This often happens during the analysis phase. In extreme cases, there are some jargon terms underlining poor practice. I'm not going to go into this. We have talked about this before in here, but p hacking and um, bias for publishing positive results and hiding negative results are some of the results that this prevents. So a nice thing about in the medical biology field with these kinds of plans is that if you publish your plan and you outline those outcomes, you're impelled by the regulatory bodies, and you have the luxury to communicate this in journals because they will accept it based on your statistical analysis plan, even if it's negative results. So it basically removes some of those elements of poor practice. Um, it also undeniably results in better data collection, higher quality data collection. For one, it assumes the right variables are measured. It helps you think through what might be covariates, things that affect your data indirectly, and encourages you to collect that data once you think it through. A thing I don't mention here, I can't remember if it's on the next slide, is that it helps you avoid collecting too little data. You've completely wasted your time if you collect too little data, and the power analysis element of these data analysis plans will prevent that. And then another big one is, you don't, you might think it's an imposition to think this rigorously before you collect your data, and you rather just talk to the statistician afterwards. But it's going to be the same amount of time either way, whether it's you or whether it's in consultation with an expert. You're going to have to put in that time to develop your analysis, and later, when you've got your results, well, you want to learn what your data contains as fast as possible. And if you have a data analysis plan ready, you're going to be able to instantly analyze that without any further consultation if it's documented, in an adequate way. So it results in much faster payoff, intellectual payoff. Um, Not only that, if there are issues, they get revealed early. Um, Here's an example with sample size, is that many data analysis plans, now this isn't as common in ecology and agriculture during the course of PhD experiments. You tend to work on a relatively short life cycle. 3 years is relatively short for measuring large, long processes. And but nevertheless, you may be undertaking a data collection exercise that takes a long time, maybe years. And one of the things you build into data analysis plans is if there's an interim step, a stopping point where you analyze the data for the first 2 years before you collect the third year of data. And it allows you to build into the plan the opportunity to adjust your data, also to find confounding variables and whether or not the original plan was feasible. It streamlines all of the parts in the reporting and documenting your analysis, coding, decision making later, because you've already documented the plan and it's just a stepping stone through the garden sort of affair. Yeah, and finally, I guess it's a bit redundant to say it avoids analysis paralysis, but you do have the stats consulting option here. But oftentimes, there are multiple things that cause a delay. One is you have to wrap your head around the data. Maybe you have to enter the data. Maybe the data are not tidy, which we talked about a lot in here. And by having the plan in place, you already have a plan, you already have your data dictionary going, and you already have probably read in the data based on the code part of your data analysis plan. Now, I've started putting in these citations. Um, Here are some that I think are real, real good ones. I think if I had to pick, one of the best ones is maybe this Gamble et al. It has Doug Altman, who's just famous he's a famous statistician basically, but he's also very famous for communicating complex ideas in a simple way to applied scientists. He had a long running series in the journal, the American Medical Association, based on basic stats techniques that's really popular. It's worth actually looking that up. Another one is this first one, this Cressman paper, that I think is pretty good. It's in a very small journal, but it has been cited quite a bit. And I just liked this paper when I came across it. Some of these others are focused on statistical analysis plans, and sometimes that means medical biology, but there's still good stuff in here. Anyway, if you like that sort of thing, those are some citation for you. So let's look at the templates. Now, if you go back here, I'll just drop this in the old message again, and you want to follow the template file. Now, I already have this up. If you look down in the very bottom of the screen, you can see there's a big long URL there that will come up, and it's part of a, I'm just going to open it by the link. If I've put this in I just got the idea. I had a few little cheat sheets that I used to have a cheat sheet repository, and for some reason, I deleted it, and I decided to make a new one with cheat sheets and templates. I don't have a lot of them populated in here yet. I have a little directory to the cheat sheets, but I'm going to populate this over time. I have a little cheat sheet for Git and one for Premiere Pro, which I use sometimes. And then for the templates, I only have the the data analysis plan at the moment with the example. And what you can see in here is the template in plain Markdown, the template in Quarto Markdown, and then the PDF that results from compiling the Quarto Markdown. So what I'm going to do is I'm just going to open up an editor. Let's just look at it first in GitHub. Let me talk you through the sections. I'm just going to make this font a little bit bigger so it's easier to see. Now, this is the Quarto data analysis template. You can see it right there. It's got the .qmd extension. Now, to work with these files, most people will want to work with RStudio. You're going to need to have Quarto installed. If you haven't installed it today, it's probably more involved unless you're real confident just installing stuff fast. It's a bit of a download. It's a framework for compiling Markdown-like documents to web pages and to PDFs. If you want to follow the example, you're going to need Quarto. That's one thing. Second, if you want to follow the example, you're going to need a way to compile to PDFs in R. And the one I think that if you try to run this, if you try to compile it, and I'll talk you through that in a moment. If you try to compile it and you don't have a LaTeX framework installed, it's going to prompt you to install TinyText or something similar, which is just a minimal one. Now, that begs the question, what is LaTeX? I'm digressing a lot here. LaTeX is a really old mathematical language, and I will raise it when I show you my example, because I've used some LaTeX language in there, like I do in a lot of my presentations and a lot of my reports, and I'll show you what it is and show you what it looks like. It looks a little bit ugly, but it's nothing to be afeared of. Now, at the top of this file, does anybody recognize what kind of code this is at the top of this file? Anybody recognize this code? If you do, yeah, it's YAML, YML or YAML. This is a type of code that is used as metadata for many kinds of tasks where there are multiple files and there is an engine that is conducting business for the instructions you're giving it in, let's say, a Markdown file. Now, there are many ways to use one of these, and they're optional. But for Quarto files, the easiest way I've found to set up your outputs is to go ahead and make a YAML file. And one of the hardest, YAML is really easy to use. You just have to wrap your head around it and, use an example and then edit it to your liking. But the hardest part about using it, even though it's very easy to use, is figuring out what the commands are. The commands are entered like this. So in this case, the commands are specifying fields in a document that will be output by my instructions and code below the YAML header. The header is demarcated by these 3 dashes, top and bottom. It's got a title command. I've just generically named this so you can adapt this to yourself, to your own data analysis plans. The subtitle might be the actual title of your project. Author would be your name. If you specify the special value today, it'll give you today's date, where you can specify a date. The format field has some subheadings. Notice under these commands that subheadings have a 2-space indentation, and this will not run if you don't have that indentation perfectly. And then there's a sub one, so I've specified the format to be PDF. There are other values possible, like HTML, and you can output to, if you have the right things installed, to many different formats, to PowerPoint, to Word, and many others. So you'd have to look at the Quarto documentation, which is really easy to access if you wanted to do that. But for PDF, there are also some subcommands. So it might give you the class of the document, which here I've specified as an article, the geometry, so you can set the margins, font size, 11 points, line stretch, it's just the spacing of the lines. Do you want a table of contents? Set TOC to true. How far do you want the table of contents to go? If you have a lot of subheadings, you can go as deep as you want, but for a relatively short document, well, let's say it's relatively short. I don't want to shock you when I show you the example. I'm only going to go to the first major heading type, so it'll be a relatively short index. You can write many people do use LaTeX and similar tools, and I suspect even Quarto to write your thesis for the brave. In some fields, that would be very common, like in mathematics. You'd be expected to write your thesis using some form of LaTeX or a Markdown. So you'd have this to the maximum depth possible for something like that. You can write books as well. Anyway, I digress. Number of the sections, yeah, you can number the sections. Color links, yeah, you can color the links. Do you want to keep the LaTeX syntax? Nope. If you have figures, what is the dots per inch? 300 dpi is the minimum you want for these kind of documents. So these are standards. I've got a few here, right here at the bottom, that I have commented out. I would usually do this for my own professional reports that I use a system like this to do. I used to use R Markdown for my reports a lot, and I will never go back. Quarto is superior in every way for R than R Markdown is itself. But it's also made by Posit, the same company that supported the development of R Markdown. So it's the modern version of R Markdown, if you will. But you can specify your bibliography. To do that, you need to specify a .bib file, which is one of the standard bibliography format types for outputting them. Any of the main reference software, I don't know, I can't remember, I can't keep up with what the university lets you have access to. Does anybody know what the official Harper bibliography software is that you can use through the library? If anybody does know and use a RefWorks, okay. Yeah, it's one of the big boys. This is a personal choice, but it won't surprise some of you to learn that I avoid commercial solutions in my workflow. I like open source solutions where I can. And the one that I chose to love and use for a really long time now is Zotero. It's open source. Started life as a plugin for the open source browser Firefox. It's served me very well for, close to 2 decades now. And you can just output bibs, but RefWorks will work. Oh yeah. Oh, if you try Zotero after one of these commercial solutions, it's just crazy. So anyway, I digress yet again. You can just output your .bib file from any software basically, and you can also output the style. Now I have the APA. The .csl format is a definition for the bibliography style. If this stuff is new to you, it probably is worth doing a session on this. I just love this. My very first job in academia was curating a load of references for taxonomists. I was an undergraduate when I did this, and I learned all about bibliographies then, and I've just loved them my whole career. Anyway, I digress again. My preferred one is Harvard. One of the preferred ones is Elsevier Harvard. So I'd probably use that, but I've just done this out to keep it simple. Now, what are the major sections? The title. You need the background and objectives with a subsection for background and objectives. You need to clearly state the analysis objectives. I'll show you what this looks like in the example. Probably the longest section, at least in my world, the most important section is the data and statistical methods, where you're really going to say exactly what statistical models and methods you're using. You may not actually know them here. And so if there are some alternatives and you're going to need to find the best one, you would explain that in this section as well. Exactly what data you're collecting or where the data comes from, if you're collecting new data and adding it to existing data, that's where you want to explain that stuff here. It's nice to formally state what the variables you're collecting are your independent variables. And of course, explain what your dependent variable is, your expected effect size and justification of sample size, what your experimental design is, if it's relevant to include pictures or diagrams, that could go here. Description of the variables, this would be like a data dictionary. So what the dependent variables are, key predictors, so the ones that are the most important, those will be the ones that are going to be in your default statistical model. In linear model language, and most of us will be using linear models for this kind of stuff. This is where your main effect variables would go. If you do have covariates, we don't really call them covariates a lot these days. It's a bit of language that's held over from when we used to call models with more than one predictor multivariate models. But anyway, if you call them covariates, that's fine. Just to identify them here. And if you have grouping variables, whether you call them blocks or random effects, you would explain those here too. Data handling and quality control, explain what you're going to do when you're going to exclude outliers, what you're going to do if you come across missing data that just can't be collected for whatever reason. If you're going to do transformations to the data or derive variables, create new features from variables that you collect. You describe all that here. Your analysis strategy, what's your approach, exploratory versus confirmatory, what your modeling philosophy is, you might even mention things like this would be very formal. We wouldn't typically do it here, but it would still be an element of best practice that would make many experts smile to see a formal statement of your alpha value, what you're going to compare your p-value to. You could also mention, what framework you're doing. Most of us, we've mostly talked about frequentist statistics in here and inferential statistics with linear models, but maybe you're a Bayesian and you want to explain that here and how that would affect your outcomes. And then finally, you want to break it up. If you're gonna collect a lot of data, go ahead and explicitly state your statistical model. Something you could do in this section is I didn't quite do this myself, but you could actually create the code to analyze your data. You could even create mock data at this point, but the minimum code that you would want is to justify your sample size if you do, for example, a power analysis. Secondary analysis, if you're going to do some exploratory or summary experiments, report the effect sizes, that sort of thing, that would go here. Sensitivity analysis, that sort of thing would go here. You'd outline your outputs and how you're going to report this in the outputs section. And then finally, if you do create some resources when you're doing this, I've just in this example, I've just put those same citations I put for the data analysis plan. So that would go in this section. You'll see when I show you the example right now that I have an additional section that I thought was best for my example. And that additional example is I've added an appendix. And in the appendix, in addition to just reporting the power analysis, I've put 100% of the code for the power analysis that is part of the example. And also, I'll try to remember to point out that I really did two kinds of power analyses. A first pass one, It's the kind that we often talk about in a first meeting if these ideas are new to you in a stats consulting session. But I also did a rigorous one, and I'll make the distinction between those. So that's what it looks like. What I'm going to do now is I'm just going to show you how to compile. Yes, because the emphasis today is on the data analysis plan itself and not necessarily using RStudio. I'm not going to use RStudio to demonstrate this compiling because the point is really just to demonstrate what the PDF will look like before I go into the example. Instead of RStudio, I'm going to use my my preferred coding environment these days, which is Cursor. A Cursor, you've done some programming in other programming languages than R. Cursor is based on one called VS Code. I'm just going to make the text a little bit bigger for people. This might be too big and we might run into all sorts of problems. So I'm just going to do this and explain the layout of what we're looking at. At the moment, this is called the Cursor IDE, an interactive development interface. IDE sounds all fancy, but it's really RStudio is an IDE. And this one looks a little bit different than RStudio. It's actually a little simpler than RStudio. And up here, I've picked this directory that belongs to that GitHub repository I showed you the link to. And in it, it's got my template markdown and my Quarto markdown. I'm just going to open the Quarto markdown. This is what we just looked at. If I scroll up to the top, we can see the YAML header. And I'm in a terminal now. This is similar to the terminal that's in RStudio. In fact, it's exactly the same software as would be in the Bash terminal in RStudio. And what I need to do to run this is to run the Quarto render command. Now, this would be exactly the same command you would run in RStudio. Although in RStudio, one of the purposes of RStudio is that you don't have to be a highly technical user to get a lot out of RStudio, and there are buttons you can push, but there aren't in this program. So I'm going to show you the command instead. So this is how you do it: Quarto render, and then I have to type in the path to the file I want to render, which is this template data. I'm going to go ahead and delete the PDF. Because I'm going to make a new one. There we go. So that you can see it pop up. And so I need to go into the templates directory. And then I need to go into the data analysis plan directory with no space. And that's where I need to name the file, which has got a long, nasty name. I just realized that. I usually don't do that, but it is explicitly clear what it is. It's templates, data analysis, and .qmd. And just keep your eyes up here when I hit enter. Some stuff will go by fast down here in the terminal, but if you can see the, oh, I'm missing the Q. Thanks for that. I would have figured that out, but it's probably faster. Just going to hit the home key and put in the Q. You're very quick at catching typos, so thank you for that. And if I just hit enter, keep your eyes up here and we'll see the PDF pop in. 3, 2, 1. Oops, I've got an error. Let's see what the error is. No invalid. Okay, so I've made a typo somewhere. What have I done? Bring back up that command. Quarto render. I've got templates. I've got data analysis plan, and I've got template data analysis planned. I've misspelled that. Yes, thank you guys. Let's do it. There we go. We've got some intermediate files popping in up here. And then before it finishes, it tells tells me that all those intermediate files are removed. It would do exactly the same thing. Now I'm just going to open this in Explorer and open the PDF. This is kind of exactly what it should look like. We've got our top part up here, table of contents. The numbered sections are automatic. You don't have to number them explicitly. That is good and bad, because if you're writing a long document, it is good that you don't have to pay attention to it. But the thing you do have to pay attention to if you're using multiple levels is to keep your levels straight. So this is basically pretty boring. It's bog standard. You can add what you want into here, and it's just like we went through for the Quarto Markdown file that we looked at. So I'm going to close that, and I'm going to open up the example, and I'm just going to briefly, probably going to look at this on GitHub. I think it'll be easier to see. Maybe I'll stay here because the syntax highlighting is nicer. Let's just go up to the top. Now this has got the exact same YAML header. I've just added in some of the information. This is a study that is looking at the effects of wildflower strips on pollinator species richness. You know, these amendments, I know I'm talking to an audience that will know what I'm talking about here, but if there is anybody that doesn't know what I'm talking about, it's this idea that we can improve the quality of the environment and create food and a more favorable ecological niche for pollinators by using the strips on the borders of fields and planting wildflowers in them. And there's all sorts of reasons why we might want to do that, like increasing the efficiency of pollination, the ecosystem services, if you will, and also just to prevent the decline and erosion of biodiversity. So I've used some specific words here, species richness. That's just a measure of the number of species. Anyway, kept the date to today. Now, a typical background section would be pretty brief in one of these. And what do I mean by brief? That's, God, what an ambiguous thing that is. But I used a real design for this to give you an example of what I mean by brief. It's not usually as long as a full introduction section. And it usually has key citations that justify things like the motivation for the experiment, but also maybe provide, like these do, provide information about the effect size if you don't have any pilot data. So this section is 3 paragraphs, and it just explains the study, and it has a couple of citations in it that are reviews or meta-analyses that explain the idea for this particular experiment. Also, there's a section here for constraints. It's an observational study. Farms are not randomly assigned to treatment conditions. One of the assumptions of all statistics is that you randomly assign, let's use the metaphor first of patients in a clinical trial. Well, you don't go to the patient and say, hey, are you taking the placebo or are you taking the drug? Instead, you go to the patient and you randomly assign them to the placebo or the drug arm. It's the same. It's the same consideration for farms, but with this kind of study, we're not usually assigning farmers to a control or a treatment trial. Instead, we're opportunistically going and saying, hey, are you doing anything like this so we can include you? So this formally violates the random assignment assumption of all parametric statistics. It's just that we accept that bias and try to mitigate it through balancing the choice of like and comparable individual units of study here. So anyway, I lay that out here. I'm not going to belabor that point. It also says that there's a limited amount of time collecting data during peak pollinator season. That's just 12 to 16 weeks and over only 2 years. So quite a short study to detect something for something like this. The objectives, laying out the objectives really clearly. It's looking at the effect of wildflower strips on pollinator species richness, just like it said in the title. And we also want to quantify the magnitude of the effect size. An assumption going into this, well, you'll see that calculated some pretty good estimates of a minimum sample size required, but the pairwise comparison of the mean of that species richness, the the rule of thumb guess was that it was low. And Cohen's rule of thumb for Cohen's D to compare two mean species richness here is 0.2. So that was the starting point with this, even though there was some actual information here. So that's a bit of context. There are some secondary objectives so that we can get through this. I'm not going to spend the time to go through this. The data and stats methods. It's standardized field surveys using pan traps. You can read that. I'm not going into the technical details of the identification or whether it's going to be species or operational taxonomic unit, but it'll be something like that. The independent unit and especially the individual sampling event. Okay, so it's pan trap collection that's nested within individual farmers' fields, and those fields are nested within farms. So the design is to do some sampling in one field with strips and one field without strips for each of these farms. And a real important part is that the farm itself is a blocking factor here. We're not actually interested in the differences between farms. We're interested in the differences between whether there's strips or not. And so we're going to treat that as a random effect, farm as a random effect. It's quite easy to understand the etymology of random effects in this study in particular, because by treating farm as a random sample of all the farms, we don't care about these 30 farms we're going to study. We care about making an inference for any farm with wildflower strips. And in that spirit, we interpret our sample of farms here as a random sample of farms, and that's the origin of the terminology of random effect for these kinds of models. So we're going to statistically remove the effect of the differences between farms because we don't care about these 30 farms. We want to make that inference. That's all you need to know about linear mixed effects models in 60 seconds. Now, I'm not going to go through the sample size calculation per se because we don't have enough time. Instead, I'm just going to go quickly through it. I've done power for Cohen's D set to the low sample, but I didn't stop there. I went on. When I calculate that, if I've done this exercise with any of you guys, you'll have probably gasped when you see for a low effect size exactly how much sample power you need. You need a lot of samples if you're going to detect the effect with 80% power. I think I even opted, just for fun, 90% power for this example. But I went on because if you're using mixed effects models, it radically increases the power of your study. So when I did these further calculations using linear mixed effects models, power analysis methods, we come up with a desirable sample of about 35 farms. Okay, and we're going to sample them multiple times through time. So this is a pretty big sample. It's the 35 farms, 2 treatments, and then 8 to 10 samples per farm over the 2 years. Define the variables. talked about the outliers and how we're going to assess the quality of data. Talked about any transformations, possibly square root to this is a bit controversial, but ecologists love doing this kind of thing. It's controversial for statisticians, not ecologists. Square root transformation of quantities like species richness might be used to adhere to the assumptions of a general linear model, mixed effects model. I want to go down quite a long ways till I get to the appendix. So here's the references, some methods references. And what I've got in this appendix is the code for the power analysis. We've done this kind of thing in here before. We always cover the simple stuff, but I've included a real, when you get into linear mixed effects models, there are no standard methods to analytically calculate power. That may surprise you. Instead, the most rigorous way, and it's also efficient, that isn't unnecessarily mathematically onerous or fancy, is to simulate and bootstrap your expected outcome. And so this is the code to do that. I have demonstrated code like this. I don't think I've done this exact study in here. And then this is for the mixed effects model right at the end. I have demonstrated this in these meetings here before too. So you can look at this yourself. I'm going to go ahead and do it, and then we'll look and see how the report looks. So to do this, I'm going to bring up, I've just clicked up a few times like you can in every terminal, and I'm just going to edit this a little bit. Example, and then the file here is VAP example. Now, in order to do this successfully on your machine, if anybody, I'm just going to delete this so we can see it happening in real time here. If you wanted to run my code here, in addition to having some version of a latex engine and Quarto, like I mentioned before, you also need to make sure you have all the libraries I call. The easiest way to do that would not be to pour through all the code and get them all installed ahead of time. The easiest way would be just to run this code I'm showing you right now and let the error messages come up and install them until it runs properly. Anyway, keep your eyes up here. You'll see a bunch of intermediate files pop up, and then hopefully it'll just land on the PDF. Hopefully it runs the first time. 3, 2, 1. It's doing the simulation, which takes a few seconds. Can't remember how many I left in there. There are the intermediate files. It's finished running. Let's look at the PDF together. I'll open it up. Well, we can look at it in. It's another nice little thing with cursor and VS Code that it has this little viewer here that's not too bad. I'm just going to make it a bit smaller so we can see it. Doesn't have a slider down here, but it has the thing on the side. So, and this might be a little bit small. Actually, I'm just going to go and look at this so I can get the full screen. Okay, so I'm going to go through this pretty quick just to give you a feel for what it looks like. It's perfectly reproducible. You can edit this stuff. This would be a rigorous report. One of the things I wanted to point out is that the full statistical analysis report, this looks like a lot. It's around 16 pages. And then the appendix itself is around 5 or 8 pages. Almost had a sneeze there. I just want to page through this to show you what it looks like. One of the things I wanted to mention was that one of the nice things you can do in here is you can specify equations. Now, you can do this in Microsoft Equation Editor, but that's like living in a cave, like I referred to when we first came. And if you try LaTeX, it looks like latex with some capitalized letters in there. You will never go back, and it's reproducible. You can always do it, and it tells exactly what your statistical model is. And we're out of time, so you can look at this yourself. We can even talk about this more in the future if people want to. But I just want to go down and show you the appendix. So if you want to share code and document that, that's what it looks like in a document like this, and you can see how that's done in the Quarto Markdown document. Any comments or questions? We're just out of time. Any comments or questions about this? I think one of the things that I was thinking of when I was doing this, I had a lot of fun doing this. This is my favorite thing to do, is building templates and thinking about citations, and especially building power analysis. But the thing I was thinking of is that there really aren't any good resources just for ag and ecology on and I forgot to mention earlier the animal sciences. They do have actually a little bit of overlap for statistical analysis plans, like in human medical industry. The 3Ds, or the 3Rs, I mean, with the reduction, you're meant to justify your sample size in these, and they have a form of reporting this and documenting that is parallel to statistical analysis plans, and yet the practice is much more lax than it is and rightfully so for ethics and legal reasons, but for just the practice of science, there's no reason why the standards shouldn't be as rigorous. Anyway, there's no good specific reference for those kinds, for our kind of applied scientists. And I just wondered if some generous person would write a book about it someday that covers the modern best practice for power analysis using ag and ecology examples, and to develop a statistical analysis plan, because I realize there are lots of parts of this that are technically demanding, especially the power analysis part, but even some of the others, like specifying the statistical models that we really don't train students for in our fields. I don't know why. I think about that a lot. Maybe one day when I have a lot of time on my hands, I would endeavor to write such a book to help the world be a better place.